Alright, our first lesson for Unit 6 is talking about variation. We have 3 different types of variation: direct, joint, and inverse. You may have heard of some of these when you guys were in Algebra 1. So we're going to be revisiting these concepts before we expand upon them further into Unit 6. So the first type of variation we're going to talk about is direct variation. You're going to notice that there's going to be 2 variables when we're working with direct variation, and our relationship between those variables looks like this. You'll notice that you have one variable over here, and then you have k times the other variable over here. It doesn't have to be y and x. It could be a, b, n, m. It really doesn't really matter. But you're going to have one over here, and then you're going to have a relationship with multiplication, k times whatever the other variable is on the other side of the equal sign. So while y and x can be represented with any variables that the question chooses, k is always represented with the letter k, and it's called the constant of variation. That's an important vocabulary word for you guys to remember. The constant of variation is the kind of the glue in this relationship. It gives the specific relationship between the y and the x and how they're related to one another. So the constant of variation is always represented with a k. It's quite similar to the slope for a line. You should notice that this kind of looks like the equation of a line without the y-intercept at the end. So the k, if you were graphing them and we're looking at the relationship, it would be linear, and the k represents the slope, which is constant for a line. So that's why in this relationship with directly proportional, we call k the constant of variation. So the kinds of questions you guys might see are represented here. They're kind of like word problems. We're going to see specifically what word problems would look like on the next page, but we still want to treat these like word problems. We still want to underline or circle important information so we can use that as we're going through the question. So it first says find the constant of variation, right? So that's why it's important to understand your vocabulary. They don't straight out say find k, right? They say find the constant of variation. You have to make that connection that the constant of variation is k in this equation. So they want to find the constant of variation and the variation equation. So that means you have to find k first, and then the variation equation is going to be this right here, but with the value of k plugged in. I call this right here the skeleton equation because it's kind of the bones or the foundation of this relationship, but it's not filled out all the way, right? It's a skeleton, not a full body equation. It's not going to be the actual variation equation until I know the value of k and I plug it in. So while it looks like this, where it's just variables and no numbers, that's the skeleton, and that would not be what the question is asking for. The equation they're asking for is this relationship with k defined. So there would be a number in the place of k. So they want us to find k, and then once we find that, actually write the equation, right? And the way that we're going to do that is by using this piece of information. They're saying that y varies directly as x, and y is equal to negative 24 when x is 4. So the fact that it's varying directly, I circle that word because, again, we're going to be learning 3 different types of variation. So when you see one of those, whether it's direct, joint, or inverse, you want to circle it so you know what's going on. And then I actually like to write above that word, jot down the skeleton equation again for myself, because you guys do need to remember what the skeleton or this relationship looks like for all 3 types. So I jot it down above the word to remind myself. And then I'll notice that they gave us 2 numbers. So I'm going to use that information and see where it takes me. So if I take the negative 24 and plug it in for y, and then I take the 4 and plug it in for x, I'll notice that I have this right here. The only thing I don't know is k. So they gave me some numbers so that I can find the first part of the question. I can find k. That is almost always what you're going to do for these questions. The first thing you're going to do is solve for k, because you can't really do anything until you know what k is, because otherwise you don't have the defined relationship like it's asking for here. So the first thing you're going to do is solve for k, and that should be pretty quick mental math. K is going to be equal to negative 6. All right, so we've answered the first part of the question. They asked for the constant of variation. That is negative 6. The next part of the equation or question is asking for the variation equation. Now we can write down this relationship. That's what it's looking for when it says the variation equation. You have to define k based on the information that they gave in the rest of the question. So the variation equation looks like that, and our constant of variation looks like that. So we've answered both parts of the question there. This one, it's not asking for the same types of information directly, but you still need to use these two pieces of information to solve this. So it says if y varies directly, so again I circle that word because it tells me what type of variation, and I just jot down the skeleton equation. All right, it varies directly as x, and y is equal to 15 when x is equal to 3. I'm going to go ahead and stop there for a second. So again, they gave us the same kind of situation as up here. They didn't specifically ask for the constant of variation, but I can't do anything with this relationship until I've defined it. So even though they didn't specifically say find k, we're going to do that first. And that is always what you're going to do, find k first. So they gave us 15 is y, and then they gave us that x is 3. All right, so the only thing we don't know is k. So we're just going to do a little bit of mental math to find it. If you divide by 3, you get k is equal to 5. So now they didn't ask for the constant of variation, but we need to find it anyway. Because in order to find y when x is equal to -2, which is the fundamental part of this question, we need to have the relationship, right? We need to have the relationship between y and x, so that the only thing that's missing is a y. So we're going to go ahead and write the equation like we did up here. Again, they didn't ask for the equation, but we need it in order to solve. Like this, right? So we know that k was 5. So now we have this. So now if we plug in this extra x equals -2, then the only thing we're missing is y, and so we can solve for it really easily. So to solve for y, I would have y equals 5, the value of k, which we found already, and then times -2, because that's what they said x was. And if I just do a little bit of mental math again, I get that y is equal to -10. Right? So notice how they have the little comma here. I drew this line to separate both parts of the equation. This information right here that they gave us was only to help us define the relationship. All right, so they gave us y and x in this particular situation so we can find the relationship, and then from there we can move forward to find y for a different value of x. All right, so you need this equation, you need k, and you need the equation, even though they didn't ask for them specifically like the first question, you still need them in order to move forward and do this kind of solution. So if you guys want to make some notes off to the side, in general, regardless of what type of variation you guys are working with, whether it's direct, joint, or inverse, the first thing you want to do is find k. And the directions should actually be pretty clear, or it's, the information provided will be pretty clear to guide you along. Notice that in both of these questions, they said direct variation, and then immediately after that, they told you what y and x were. So the question is going to guide you along as to what you're supposed to find in each step. So the first thing you do is find k with the information they provide, and then you're going to write, sorry, why I take forever to write this, write the equation of variation, and by that I mean write the relationship. So that means you need to have, hold on, I need to spell this. So, but this equation I'm referring to is like this, right, where you define the relationship. So you had to find k, and then when you write the equation, you plug it in, and then once you have that equation, you can go from there to solve for whatever the question is asking for. All right, so this is the general process you follow. Find k, plug it into the skeleton equation to find that relationship, and then solve with whatever information they give you at the end. That's the general process you follow. So let's see if we can apply that to this other type of variation we have here. It's called joint variation. Joint variation is a type of direct variation. This time there's going to be more than two quantities that are related. Up here we just had 2, x and y. Down here we're going to have 3 or more. It's usually just 3. You can see y, x, and z. Right, so you have y varies jointly as x and z. This is your skeleton equation for joint variation. The k is still in the same position. See how we still have multiplication here? Same thing, still multiplication, but now we have multiplication of 2 instead of just 1. Okay, so it works the exact same way. We're just throwing another variable in the mix. All right, so reading the question, I see y varies jointly, so that's my keyword here. I'm going to circle it and then jot down the skeleton equation. Now you have to make sure you're reading the question really, sorry, that's a Z even though it looks a little squished. You have to read the question really carefully because whatever's over here, this variable goes on the left side of the equal sign, and then whatever's over here goes on the right side of the equal sign. That's going to be important when we get to this question when it's a little bit different. Don't think that your skeleton equation has to look like this. Like I was saying, they could use other variables, A, B, C, W, K, or sorry, W, L, M or something. They wouldn't use K because it was already being used here. I shouldn't have said that. But again, those three variables that they give you besides the constant of variation, those can be any variables in any order. You just have to read the sentence to understand how you would write the skeleton. All right, so we write down, we know it's jointly varying or jointly proportional. They gave us X, Y, and Z. All right, so again, see, the first thing we do once we figure out what type of variation is find K, and they led us straight to it. They gave us X, Y, and Z. They gave us everything except for K, so obviously they want us to solve for it. So if we plug it in, we're going to have 20 is equal to K times, I'm going to do a little bit of mental math. If X is -2 and Z is 5, and I multiply them together, I get -10, right? X times Z, -2 times 5. And then when I divide it, I get K is equal to -2. Okay, so you always need to start with K. It says find the equation that relates the variables. So that's that equation of variation we were talking about before. And so I would have y equals -2 times x times z. Again, whenever they ask for that equation, they want you to actually define it by plugging in the value of k that you had just found. Then ultimately, they want us to use this equation to find z when x is equal to -3 and y is equal to 60. So this is going to be really simple. The only variable that I don't have provided that they want us to find is z, but they've told me that y is 60 and x is -3, like this. Alright, so we just do, again, you can use your calculator if you need to, but a lot of this is mental math. -2 times -3 is +6. Divide that over, I would ultimately get that z is equal to 10. So this is my answer to that part, and they did want me to find the equation. That's officially part of the question too, so I would circle both of these parts. Okay. Alright, next one here. Now this one, again, I mentioned this up here. You want to make sure that you're really careful how you read the equation or the sentence. I see z, x, and y, but they're in a different order than up here where I had y, x, and z. So I still have jointly varied, but when I write the skeleton equation, it's going to be z is equal to k times x, y. You write it in the order that it's presented in the sentence. All right, it's not always going to have to be y over here. It could be just be whatever variable is first, and then everything on the other side of the word jointly shows up on the other side of the equal sign. So they're in order in the way that you should write it for the skeleton. Just be aware that that can happen. They can jumble up, so it's not in alphabetical order or whatever you might expect is the usual. It can be mixed up. The next one here, we have the x, the z, and the y that we would have needed to find k. So if we plug those in, we have 3 is equal to k times 4 times 9. 4 times 9 is 36. To get k by itself, I have to divide over the 36. So I end up getting k is equal to, at first, 3 divided by 36, right? K, you're not allowed to write it as a decimal because that would require rounding, and that's going to throw off the accuracy of our number. So you're not going to plug this in and find out the decimal. You just want to write it in the most simplest form of the fraction. So our value of k is going to be 1 over 12. You can use your calculator to simplify if you want, but don't leave it as a decimal. All right, so now that I've found k, the question wants to know what the equation would be that relates the variables, and so we're just going to do like we had before. Sorry, z is equal to the definition of k times x times y. Again, they had the z first because that's the way that it was written here for the skeleton. So that's the equation that relates the variables together. Then they want us to find z when x is equal to 10 and y is equal to -2. So again, we plug in the values that they gave us. Sorry, I keep drawing my z's different. Alright, and then they give us the 10 and the -2, this. All right, so if I multiply those together, that would be negative 20. Negative 20 times 12 is negative 20, or sorry, negative 20 times 1 over 12 is going to end up simplifying to become negative 5 over 3. Now, while k can't be a decimal, your final answer for this, for the other variables, can be, so you can write it as negative 5 over 3, or the decimal equivalent, which I think is 1.6 repeating, if I remember correctly. Either one of these is fine for the final answer for z or x or y or whatever variable they want. The only thing that's not allowed to be a decimal is the value of k. All right, our last type of variation is inverse variation. Now this one is going to be different from direct and joint variation because this one is now using division. These two use multiplication to link the variables together. This one is using division. So we are back to just two variables, and this time instead of k times x, it's k divided by x. Now something that they're going to try to use to mess you up is a difference between this and this. If they have an equation y equals like this, if the variable is in the denominator, that's automatically going to be an inverse variation. However, if the variable is in the top, this is actually considered a direct variation. So don't just go by the fact that it's a fraction. All right, just because it's a fraction doesn't automatically mean it's inverse. It has to be a fraction with the variable down in the denominator with the constant of variation in the top. If it's the other way around, where the variable is up here, technically you can rewrite it like 1/2 times x. You can rewrite x divided by 2 as 1/2 times x. So this is still a multiplication situation. They just kind of wrote it a little bit different. So this is considered direct while this is inverse. So that's something you guys want to make sure that you're clear on, the difference between those. All right, the process is the same for inverse variation. You still need to find k, plug it in to find that relationship or equation that shows the variation relationship, and then solve for whatever they're asking for. So the first one, again, you want to look for the keyword directly, jointly, or inversely. This one's inversely, so we know our skeleton equation would look like this, and you do need to memorize these, what the equations would look like with the constant of variation and the position of the variables. We have y on the left and x on the right side of the equal sign. They give us y is equal to negative 3 when x is 4. So if I'm going to solve for k, I need to multiply the 4 over. So I get k is equal to negative 12. Find the constant of variation. All right, so that was part of the question. So they want us to actually find the constant of variation and circle it. They also want us to find the equation relating x and y. So that would be your relationship like we had. It's the skeleton, but with the definition of k plugged in. So it would be y equals negative 12 divided by x. That's the equation that they were looking for that relates x and y. And then finally, they want us to find y when x is 6. So in order to do that, we would just plug in the value of x, and we would get negative 2 for y. All right, pretty simple, just like the ones up here. You're just using division this time. This one, again, is inversely. All right, so we have our skeleton equation over here that we're going to be working with. Y is equal to 10 when x is equal to negative 2. Let's solve for k. You're going to multiply the negative 2, so k is equal to negative 20. That's part of the question. They wanted us to find the constant of variation, so I'm going to go ahead and circle that. That's officially one of the answers. They also, just like above, want the equation that relates, so we're going to have y is equal to the definition of the constant of variation, which is negative 20, divided by x. That's the equation that relates the two variables together. And then based on that, they want us to solve for y when x is equal to 4. So y is going to be equal to negative 5. Okay, so just make sure you're reading the questions, circling the word jointly, directly, or inversely, whichever you guys see. Write down the skeleton equation so you know what you're working with. Find k, plug it in, solve for whatever they're asking for. Just read through the question, it's all there. At the bottom of the page, we have something called combined variation. It's where they take two different types of variation and put them in one question. The only thing you have to do differently here is you have to combine two different skeleton equations together into one. The way that I do this is I write the skeleton equation for the first one. So for instance, this says y varies directly as x, so I would write that out. You have to memorize what that would look like for directly. It looks like this. And then I'm not going to write a new equation, I'm just going to add on to this and represent inversely as z squared, where inversely is division, so it means I have to have divide, and I'm dividing by z squared because that's the other part of the variation for the inversely. So I have the direct variation right here, and I have the inverse variation right here. The k is being used for both of them, right? So this k represents the direct and the inverse variation. So that's two things all merged together into one, right? And then the process for the rest of this is the same. They give us y, x, and z, so I can plug them in to find k. So k times 5, and then z is -4. Be very careful. This one has a z squared. It's a little bit weird, I know. But whatever this is, if it's a smiley face, a star, whatever it is, that is your denominator for the inverse relationship. So just make sure you remember that the square is there as you're working through the problem. So -4 squared is a 16. If I just do a little bit of mental math here, if I take this and square it and then multiply it over, I would get 32 is equal to k times 5 still. To get k by itself, I divide by 5. So k is equal to 32 divided by 5. All right, just use your algebra skills to get that out of the way. So remember, this can't be a decimal, and it can't be simplified, so I'm going to leave it as 32 over 5. They want us, so I use this information to find k. Beyond that, they want us to find y when x is equal to 7 and z is equal to 12. So we're going to plug in everything that we know, and the only thing we don't know is y, so we're going to solve for that. So y is equal to, this is where k belongs, so I'm going to type in, or write the value of k, all right, and then times x divided by z squared. All right, again, don't forget the square. So for this one, you guys want to be really careful as you're entering it into your calculator. I recommend that you find the top number first. Let me just do that really quick. All right, find the top number first, which is 44.8. And then divided by 144. You don't even have to write it down. You can just find it in your calculator first and then go straight into dividing by 12 squared, which is 144. And you're going to get something like this. 0.31 repeating. Right. If we do the next one here, this is a combined variation with joint and inverse. So it says y varies jointly with x and z. So I'd write y equals k times xz, because this is what it would look like, the skeleton looks like for jointly. But then in addition to that, we also have an inverse relationship with v. So inverse variation looks like this. So I have the division v, so I have the joint and the inverse all together in one equation. Okay. This little bit right here, again, the next thing that they're going to do is give you all the information you need to find k. They give you the information in order of what you would do. Okay, so we're going to use these numbers to find k. 10 is equal to k, x and z is 2 times 3, which is 6. I'm just going to combine those together. And then v is 6. Okay, so if I solve for k, ooh, I made that too long. Hold on, sorry. I went a little bit crazy with that line. All right, so if I'm going to solve for k, I need to divide the 6 over. Sorry, multiply the 6 over. Making ahead of myself. You need to multiply this 6 and then divide that 6. So ultimately, basically, these cancel each other out, and you get k is equal to 10. You can do that however you need to do it to understand it, but ultimately those cancel each other out, and you're just left with k is equal to 10. All right? We're going to use that to help us find v, because now that we know k, and they're giving us y, x, and z, the only thing we don't know is v. So if we plug everything in, we're trying to find this. Y is 2. I just found the constant of variation, so I'm going to plug that in. And then I know that x is equal to 5. z is equal to 1, and v is what I don't know. Alright, so I need to go ahead and simplify this a little bit. So I have 2 is equal to, if you multiply all that together, you get 50 divided by v. Alright, so to get v by itself, it can't be in the denominator. So anytime you're trying to cancel out a denominator, you always multiply like this. Alright, so it becomes 2v equals 50, right? And then you divide by 2, and you get v is equal to 25. There you go. Even though the variable's in the denominator, you still do that same thing. Like we were doing over here to get rid of the negative 4 squared, we multiply times 16, right? Same thing, even if you have a denominator of you have the variable in the denominator, you still need to multiply to get it out of there, and then you would just divide the coefficient y. Alright, so that's combined variation. Just be careful when you're writing the skeleton, but the rest of the equation works the same. Alright, here we're going to be practicing identifying what type of variation exists. So we're going to talk about equations here, and then table of values down here. And in the middle, we're going to talk about how to do the same questions we just saw on the previous page, but in the context of word problems. And then that's all that we need to know for these. So these first three are already set up for us. You can only tell what type of variation it is if you have it solved for one variable on the left. So this one is y equals 13 divided by x. Because this one is division with the variable in the denominator, this is inverse variation. This one is a multiplication. All right, the constant of variation, or k, is negative 1.2. And since this is multiplication of the constant of variation times one variable, this is a direct variation. Again, the better you know the skeleton equations, the easier it is to see these. So make sure you're working on remembering those. This one is multiplication again, but this time I have two variables on this side. Two variables being related to one, that is a joint variation. Okay, so we have one of each there. Now the rest of these are not so straightforward because they're not set up correctly quite yet. So this one I can't have two variables over here. I need to have one is equal to everything else. So I'm going to go ahead and solve for y. You could solve for x if you wanted to, but I'm going to solve for y. I'm going to subtract the x over. So notice here that I don't have any multiplication and I don't have any division. In order to have direct or joint variation, you need multiplication. And in order to have inverse, you need to have division. And none of those exist. So if you have addition or subtraction, there is actually no variation going on here. So you would just say none. There is no variation there. This one, again, I need to have one of these variables, not both of them together here. So I need to have one variable is equal to the other. So I'm going to solve for x this time. Again, it doesn't matter. You could solve for y, you could solve for x, whatever. I'm going to solve for x. That means I need to divide the y away. So I would do that to both sides, which ends up with the y in the denominator over here. Because this turns into division with the variable in the denominator, this is inverse variation. Looked like multiplication before, but when you get the variable by itself, it becomes a division. Over here, I do have z isolated, but let's go ahead and get rid of that 2 really quick. This is what I end up with when I do that. This is automatically joint variation, simply because it has 3 variables. But this is the situation I was talking about on the previous page where you have division, but the variables are in the top and the numbers in the bottom. So this is still considered multiplication. You could have written it like this as well. All right, which may be a little bit more clear to see that it's joint variation. But again, this would not be considered inverse just because there's a fraction. You need to be really careful when you're looking at it. This one has division, but remember, you can't decide what type of variation it is unless you have one variable and then everything else on the other side. So I need to solve for one of these variables. The easiest one to solve for would be y. So I'm going to go ahead and multiply times x on both sides to cancel that out. So I'm going to have y is equal to 2x, all right, to get a linear equation here. And that ends up being multiplication on this side, which it would be a direct variation. Alright, so always make sure it's solved for one of the variables. It doesn't necessarily have to be a y, but just make sure you have one variable on the left and then everything else on the right, and use that setup to determine what type of variation. All right, so for word problems, we're not going to be using x and y in our skeleton equations. We're going to approach these questions the same way that we did on the other side. We need to find k first. We need to plug numbers in to solve for the variable that they're asking for, all the same stuff. The only thing that's different is that it's a word problem, right? So they're going to be referring to specific dimensions like volume or radius or rate or depth or height or length or things like that. So when we're creating the skeleton equations, we want them to look like direct variation, inverse variation, or joint variation, but we're not going to be using x's and y's or anything like that. We're going to be using variables that make more sense for the context. So for example, and this one over here wants us to write the equation for this variation relationship. So I noticed that the things that we're relating together, the two dimensions, I'm relating the volume of a sphere to the cube of its radius. All right, and I like to circle this word again because it tells me what type of variation. So instead of using x and y, I'm going to use a v and an r cubed to represent these two things that I am creating a relationship between. So that's what I mean by finding variables that make more sense for the situation. So this one would be v equals k times r cubed. K is the constant of variation. It will always be k. K is constant, always looks like that. The variables that would have been x and y, you're going to swap those out for something that makes more sense. And I have the cube here simply because they added that detail. It says the cube of its radius instead of just the radius. So if they add any of those little details, make sure you are taking that into consideration when you're writing the equation. All right, this next one says the intensity of a sound varies inversely with the square of its distance from the source. So the intensity I can represent with an I. The inversely tells me I'm going to have division here because that's what the skeleton equation looks like. And then the other variable is, it's referring to distance, but it's talking about the square of the distance. So I would have d squared. All right. So if I'm going to do the inverse, I would have y is equal to k divided by d squared. Again, you need to remember that inverse looks like this while direct looks like that, and just put the variables in the correct position. The next one says the horsepower for a pump varies jointly. When you guys see the word jointly, you should remember that there should be 3 variables total. There's one on this side of the equal sign, and there should be at least 2 on this side. So the first one would be the well depth and the rate for the pump. So I'm going to use D for depth, R for rate, and H for horsepower. And then when I write the actual relationship or the skeleton equation here, I have H is equal to K times D times R. All right, so that's the basic idea of creating skeleton equations for word problems. So now we're going to actually work with 2 word problems. We go a little bit further. This was just practice creating the equations. Actual word problems are, again, going to give you numbers where you plug in to find for solve for k. Then you keep going to solve for one of the missing variables they're talking about in the question, just like we were doing on the other side of the page. So for this one, we have Ohm's law. Not exactly sure where that comes from, but I think it's physics. So according to Ohm's law, the current flowing in a wire is inversely proportional to the resistance of the wire. Always read the first sentence maybe once or twice to understand what's going on. Always look for the inversely direct or jointly proportional or varying, so you know what type's going on. And then find your 2 or 3 variables. If it's joint, that's the only time you would have 3. If it's inverse or direct, you're going to have 1 variable on this side and 1 variable on that side. All right. So just with the first sentence, I'm going to draw a little line. Just from the beginning to this line, it tells me that I have this equation for the skeleton. C is equal to K divided by R. Because remember, this is inverse variation, so it's going to be division. All right, so that's what I have so far. Let's keep going. If the current is 5 amps when the resistance is 24 ohms, okay, they gave me C and they gave me R. Again, remember the next thing you do is find K. And that's exactly what they told me the information, well, sorry, that's exactly what they gave me the information to do to solve for K. So I plug in 5 for C K is what I'm looking for, and 24 for the resistance. So if I go ahead and solve this, I'm going to get that K is equal to 120. Again, they have the question all set out for you guys. They're kind of leading you along. The first equation gives you the skeleton, the first sentence gives you the skeleton equation. The next little part gives you how to find K, and then the rest of it's going to tell you what do you actually need to find. So once you find K, they're going to follow up by saying, what will the resistance be when the current is 6 amps? So they're giving you a new situation where now they want to know what R would be if the current is 6 amps this time instead of 5. So we're going to use the constant of variation to help us. We know that C for the situation is 6. We know that the relationship is defined by a constant of variation that is 120. R is what we don't know. Okay, so we're going to use this equation that we just found enough information to create to solve for R. So I'm going to multiply times R to move it out of the denominator. So I get 6R is equal to 120. And then I divide that by 6 to get R by itself, and I get that R is 20 ohms. Right? And that's how you would approach a word problem like this. The next one is Hooke's law. It says the force needed to stretch a spring is directly proportional to the length the string is stretched. All right, stop there. So this is giving us the skeleton equation. We're going to use F for force and L for length, and it's direct variation. So it's going to be F is equal to K times L, because that's your direct variation type of relationship. All right, the next information is going to help us find K. If 50 pounds of force stretches a spring 5 inches, stop. All right, they gave us two numbers. They gave us the force and they gave us the length. All right, it doesn't specifically say length, but because they use the word inches, that indicates that it's going to be a length. So the force is 50, and the length is 5. With that information I can solve. I find that K is equal to 10. All right, keep going. How much will the string be stretched by a force of 120 pounds? So now we know the relationship is defined by a constant of variation that's 10. So based on that, they want to find what the length would be if the force was 20 instead of the 50 that they kind of gave us here. So the force is 120. We know that K is 10 for this situation. They want to know what L would be. So in order to do that, very simply, you just divide by 10 and you get that L is 12. Right? Just like we were doing on the previous side of the page, just with a lot more words. So just be careful as you're reading, underline, highlight, circle, whatever you guys need to do. But again, the flow of the sentence gives you everything that you need. It kind of directs you in the way that you need to go to solve. Lastly, we're going to talk about how do you determine what type of variation exists in tables or ordered pairs. Your only options are going to be direct or inverse, because there's only 2 variables instead of 3, which you would need for a joint variation. So the way that you would do this is you're going to plug each point into one of these 2 equations and solve for the constant of variation, or K. If you get the same K for each point, then whatever equation you were plugging it into, that represents the variation. So if you plug it into this equation and get the same K each time, that means you had direct variation. If you plug it into this one and you get the same K each time, that means it had inverse variation. If it doesn't work for either of them, that means that it has neither of those variations. So for example, for the first one, if I was trying to check to see if it had direct variation, I would plug the Y value here and the X value here. So I would have negative 30 is equal to K times negative 6. And then do a little bit of mental math. I would divide. I'd get 5 for K. Now, if this is going to be a direct variation, if I do the same thing for all of these other points, I should also get 5. All right, so let's see if that happens. If I write negative 10 is equal to K times negative 2, if I do that solution, I also get 5. If I have 5 is equal to K times 1, I also get 5 when I solve. If I have 10 is equal to K times positive 2, I also get 5 when I solve. So if you get the same value of K for each point, that means that it was direct variation, because you're plugging it into the direct variation equation. All right. Well, let's see if we can figure out what this one is. We're going to try the inverse variation test for this one. So for that, you'd have y is equal to k divided by x. All right, to solve for k, I'm going to multiply times 0.5, which means you would get a 4. Right? Then the next point would be y is equal to k divided by x. All right, and I use the y and the x from this point. If I solve for k, I multiply times 1, I also get 4. I would have 2 equals k divided by 2 for the next point. If I solve for k by multiplying times 2, I also get 4. And I know it looks like it's really promising, but never make a conclusion until you have all 4 of the points confirmed, or however many points they give you. 4/3 is y, 3 is x. So clearly you can see the relationship here. K does have to be 4. So when I plugged into the inverse variation equation, it all worked out with, to get the same value of k. So that means this has inverse variation. All right. Well, this one, let's see. Let's go ahead and try direct variation for this one first. So if I go ahead and write down the equation, 1 equals k times 0.5, right? If I solve that for k, I have to divide by 0.5. Excuse me. And when you divide by 0.5, you would get a 2 for k. If I try this one, if I try 2 equals k times 0.25, all right, the same equation, right? You plug in the value of y from that point and then the value of x from that point. If you solve for k in that situation, you would get an 8. So we already have a different k even from the second point. So because these two k's are different, that means that it failed the direct variation test. Now, if it fails one test, you cannot just assume that it must be the other one. So even though this failed the direct variation test, I cannot assume that it's variation. Right? Because remember, one of our options is that it's neither. So if you fail one test, you still need to check the other one because it may fail that one too. So if we check to see if it'll work for inverse, I'm going to go back to the first point. If I have 1 is equal to k divided by 0.5 this time, by plugging into the inverse, if I solve that, I would get 0.5. Right? If I plug in the next point, 2 equals k divided by 0.25. I think that one is also 0.5. If you, let me just double check. 2 times 0.25, yep, is still 0.5. So this is looking a little bit more promising. Once I get to the third point, I get 3 is equal to k divided by -4. Oh, but then when you solve this one by multiplying, you get -12. All right, so again, we ended up with a different k. So if it fails both variation tests, then you would just say it is neither direct nor inverse. That is an option. All right. So again, don't make any assumptions. You always have to check both situations in order to figure out which variation it is.